I set out to build a better utility trailer, from designing the frame to specing all the components and fabricating everything in my little garage shop, which is by far too small for a project like this. This was definitely an adventure and one of my favorite projects that I've ever built here on the channel. Hey, welcome to the shop. One of the most useful tools I've ever had was a small utility trailer, but I sold mine 5 years ago when I got a pickup truck. Well, I've since had many times where I wish I still had that little trailer, and recently getting another one has been on my list. I first considered purchasing a trailer such as this new Harbor Freight trailer, but the bolt together construction, I wasn't really a fan of that, and I wasn't really happy with any of the options from big box stores or the local builders, so I decided to set out and build my own. Now, I needed to choose the best frame material, and this could be a video in and of itself. In fact, I'll probably make one, but I settled on 3" by 2" rectangular tubing for the main frame and 1.5" square for the cross members, all out of 11 gauge. This gave me a really conservative safety factor, even when fully loaded on a rough road. So it's going to work well, and this is my shopping list for the steel yard, which is just down the road. Now, they got everything loaded up for me, and I'm excited to have this new trailer because then I won't have to rent one every time I go to pick up material. Now, in addition to the frame, there are a ton of other trailer components that you need for a build like this, and I thought I'd have to spec out my own axle, wheels, bearings, coupler, all those sorts of things. However, I found a place online that makes this super simple at a much better price. Now, these guys at Southwest Wheel have put together utility trailer kits that have everything that you need, and it saves hours of time, and it's at a better price. And all of these kits are customizable, and they ship for free and arrive in just a few days. Now, I reached out to them and let them know about this build, and they were excited to partner with me on this. So in full disclosure, they did provide these parts. I would have purchased from them regardless because they've done such a good job, and it's a huge savings of time and cost. Now, the first part of this build is just a rectangle for the frame, and my trailer is going to be 5 by 8, though it's about the same process for whatever dimension you want to make. Now, I'm cutting this on my fancy Evolution mitering chop saw. A regular chop saw would work just fine for this, but I would recommend having either a chop saw or a band saw for a project like this. Now, I want to bevel these edges to make sure that I get good weld penetration all the way around here, because this is a pretty important weld. You can penetrate through a square groove on 1/8" without any prep, but I want to definitely be sure that that works out. I'm using these little fabrication squares that I have. They're really handy, but if you don't have them, you can just tack lightly in one corner and double check corner to corner, which you should do anyway, just to make sure that everything's sitting square. And so you do a little tack at a time and work your way up to a full weld. That way you can do it without the squares. These are just a nice time saver. Now, I'm running the welds here with the HDP MIG 2800. This is by far my favorite MIG welder that I've had here in the shop, and it's working really good here today. So now I can turn my attention to the tongue right here. And for this, I have a 50-degree angle on the trailer coupler, so I want to cut these at half that, or 25 degrees, to give me a flat face on the front, and then kind of mock things up and get a feel for the exact dimensions. Now, one of the important things with the length of the tongue is I want for either of my tow vehicles to be able to jackknife it around on the tongue without hitting the box. I'm going to prefabricate this tongue before I put it on the trailer, and I'm just putting a light tack to keep the ends together before using the coupler as a fixture to install another cross member right here. And I'm installing this brace, so if there's any kind of torsion here in these parts, which isn't as big of a deal with rectangular tubing as it is with channel, but I want to absorb that there in that cross member. Now, I'm going to cap the end, and I'm using my laser here to cut out a piece, but I could have cut this probably just as fast on an angle grinder instead of programming it, but since I got the fancy tool, might as well use it. And I also capped the back ends of those tubes in a similar way, mostly because I don't want bees finding extra homes in there. Now, to prep for weld on the coupler, I ground some of the powder coat off all the way around so that I can get a nice weld here, and I'm running this good and hot. Now, I'm going to weld all the way around on both sides and then go ahead and weld the tongue in place. And I've measured to make sure that everything is sitting square on here, and it's working pretty well. I calculated the position of the axle to give the right weight distribution, assuming that it's evenly loaded on the bed. And that worked out to be about 5 feet back out of the 8-foot bed. A good rule of thumb is 60%, but I think it's worth actually calculating. I'm going to space the holes between the mounts about a ½ inch shorter than the eye-to-eye length of the spring. And what that'll do is make sure that that shackle is always leaning outward and the spring can't over-center. So that's really a best practice, about a ½ inch shorter. Now let's turn our attention to the cross members here, and I'm using 1½ inch square tubing with 1/8 inch wall. And this is really convenient because I can just line it up with the bottom of that 3-inch tubing, and that leaves a 1½ inch pocket for standard decking. Now I'm fitting everything in nice and snug, so I'll cut it a 16th inch longer than the opening, which is turning out to be right at the nominal dimension for me. So it's working out really good. Now there's a lot of welding on here, more than I'm showing, and I ended up flipping this back and forth, right side up to upside down, probably 3 times during the build. And each time I added things, it got a little more difficult. Now I need to weld the top side of the tongue here before I install the cross member, and it would sit right there against that weld, but I moved it forward just a little bit so that I could leave that weld separate and not interrupt that critical weld between the tongue and the frame rails. Now I need to add little shelves at the front and back out of angle iron, and I bought the wrong size angle. So here I am modifying the material, but if you buy 1.5 inch angle, it'll fit just right, and you'll be good to go. So I'm just using a couple tacks at the end to hold it in place before I run an intermittent weld along the back, which should be plenty for something like this. I'll add a little bit of weld underneath on the bottom also. I'm really happy with how the frame is coming together. I need to put a top rail on here, and I want to set the height of that at the same height as the top of the fender. So now I need to figure out where the fender's going to go. Well, in order to do that, I want to have a certain clearance to the wheel, so I need to assemble the axle and bearings and all of those things to really get a good size for this. Now their kit ships without the spring perches installed, which is just fine. It's a little bit of welding here. So I've measured and got everything sitting nice and square, and then I'll turn my machine up good and hot. That's one thing I really like about these HTP MIGs is they have those synergic settings, so you can just turn up the wire feed speed, the voltage follows, and you're good to go without a whole lot of messing around. I'm only going to install these bearings once, so I'll go ahead and pack them with grease. Now, I don't have a bearing packer, but using some grease in the palm of my hand, I can push it up between all the rollers, work my way around there, and it should be good to go. Then I'll install the grease seal on the back of the hub and slide it onto the spindle. Next, I can install the outer bearing as well as the spindle nut, and it won't be adjusted right now. I'm going to adjust it once I get the axle installed onto the trailer. Now, this is just a loose test fit, so I'm sliding the bolts in here and putting the wheel and tire on, and wouldn't you know it, the fender sits just right with the bottom of the fender aligned with the bottom of the frame, so I think they thought this one through. At this point, it's getting pretty hard to move around the shop. Well, now that I have that vertical dimension off the fender, I can go ahead and build my side rail, and it worked out to be about 11.5 inches to the bottom of the rail. So I cut out a dozen of these uprights, 2 of which have miter cuts, and I'm going to cap the bottoms. This is optional, you could leave them open, but I cut out these little caps that have a small weep hole in case water got in, but they should keep wasps from getting up in there, hopefully, or at least if they do, they're probably not going to get out. Anyway, it's going to, hopefully help with some of those critters. But once I have those ends capped, I can prefabricate my railing in 3 different pieces. This is the front piece right here, and so I have 4 uprights on that section, and then I can weld them out and go ahead and install it onto the trailer. Now, when I'm installing it, I'm putting about a ½ inch between the bottom of the railing posts and the bottom of the material, and I just used some material to space that out. Then I prefabbed the side rails in the same way, and once everything was tacked in place, I'll go ahead and weld this out so it's nice and solid, and we can start looking at the tailgate. Now this is a ramp gate, and so the top and bottom I'm making out of angle iron, which will help me to have a little better ramp on and off of it. And then I'm using 1" by 2" tubing for all of these upright sections. Now for the outside sections, I'm using thicker 14 gauge tubing because I want to have a little bit more rigidity, but for the center 4 supports, I'm just using 16 gauge because it should be sufficient with that tall of a section, and it's going to save a little bit of weight on the ramp gate. So I'm working my way around here, even though the welding table isn't big enough. As long as I'm careful and keep everything square as I go, I'm able to, maintain a relatively square and flat gate, at least plenty good enough for a trailer ramp gate. Whenever I'm installing any kind of sheet metal onto a frame, and that applies with this expanded metal also, I'll start in the center and work my way out from one end and then work to the other, so I don't end up leaving a little bit of a bow in the middle. Now I have the expanded metal welded on the whole ramp gate, and this is raised expanded metal. So I'm going to put the hinges on this end because these little raised portions act as cleats. And so if you have this raised portion pointing upward on the ramp when it's open, that'll give better traction than if it were pointing downward. I'm going to make my own hinges, and I'm going to use pins that are removable so I can easily remove the ramp gate. So I found some DOM tubing that has a little bit of a gap between it and this 1/2" round bar, and I'm using a full 5-foot length of round bar to keep everything aligned when I weld this together, and then I'll use that bar to make pins in the end. And you can see how easily that slides clear across. And I'm using the same technique here on the trailer to line everything up just with that round bar. And I have a little bit of a spacer made from some leftover pieces of material there to hold everything up and give a little bit of clearance between the gate and the bed of the trailer. So the bar slides out easily, at least until it hits the wall right there. I don't have enough room to actually remove it. But since I'm going to be cutting pins anyway, I'll go ahead and just cut a piece off here so I can slide the rest of the bar out and cut 5 pieces for pins, 3 for the hinges on the bottom and then 2 to keep them to keep the gate closed. Now I'm drilling holes for cotter pins in the hinge pins right here, and then I'm going to use my torch and pretend to be a blacksmith to bend the ends over, and this will make the pins. Now there's only holes in the bottom of the hinge pins. The retaining pins I'm actually going to weld onto a little piece of chain so that I don't lose them, but I think they turned out pretty good. Now in order to latch it shut, I'm going to use 2 more pieces of that DOM tubing like this, and I'm going to weld 1 piece to the trailer and the top piece I'll weld to the ramp gate. That way I can just slide a pin in there and hold it closed. Now I'm also going to drill a hole at the bottom of each of these pieces of tubing as a weep hole. In case water happened to get inside of one, it would have a way to get out so it doesn't just rot out from the inside. And I'm going to do the same thing on the trailer frame, both on the box frame and all of the cross members at each end or corner, just to make sure that if any water did get in there somewhere or another, it couldn't pool up and build up. It would have a way to drain out. It's just a best practice when you have something that's closed like this. The kit included safety chains along with these retainers, and I like to mount safety chains a little further back, or at least this is what I think would be a good idea, because that'll give me a little bit more flexibility on the positioning up front without having to twist or do weird things with the chains. I'm going to run the wiring for the lights through the frame itself, so I'm just using a little bit of welding wire to be able to fish those through later. And then I'm going to fabricate a spare tire mount like this. You could just use a long bolt that's connected there, or a U-bolt, but I like to have something a little bit more stout. So this has 3 different sections coming off of it and the same size studs as the wheels. I also laser cut these tie-down mounts. You can purchase some of these readily available online and weld them on, but I thought I'd just make my own. And I am also laser cutting out some mounts for the lights. I just got the standard lights, and I want a plate for them to mount at the back of the trailer, but also to have some protection above them. And so I drew up these little mounts that I can bend in half, and that'll add a little bit of stiffness as well as some protection in case I drop something, so they just mount right onto the trailer. The last thing I'm going to do is install the fenders. I saved these for last because I actually had to haul the trailer out on its side and I didn't want to beat these up. And once those are on, it's time to prep for paint, and I'm using some self-etching primer here before I get into the paint itself. Now for paint, I used Rust-Oleum Farm and Implement paint. This is some pretty tough stuff that you can apply with a brush or a roller. I want to learn spray painting. I definitely am brand new at this, but I bought a Harbor Freight gun and I'm giving it a try. And overall, it came out pretty good. It took a little bit of experimenting to figure out how to thin the paint just right and get everything running good. But once I did, I was getting pretty even coverage. Now for the decking, I got the longest lasting finish and sealer that I could because I want it to last quite a while. Now with all the paint done, I can go ahead and assemble the trailer, and I'll start off by assembling the axle and the wheels and tires here right onto it. I'm just running them down with an impact wrench. I'll torque them later, and once the wheel's on, I can go ahead and adjust the hub, and I'll rotate the wheel and torque this to 50 foot-pounds to seat the bearing, and then loosen it and just tighten this finger tight, and then back it off to where the retaining clip or the keeper can hold that right in place. I should have just very, very minimal play in the bearing, and it should rotate freely. If you get these too tight, they can really heat up and add a lot of wear. And with that finished, I can add my grease cap, and the axle is done. And once I put it back on the ground, I'm able to torque these nuts down to right around 100 foot-pounds. So this is the light mount that I made for the front, and anytime I feed wires through the metal, I'm using a rubber grommet to make sure that they don't chafe and wear through the insulation, and that worked out great. You can see that tie-down mount up above the light mount there on the front. Now on the back, I have these light mounts that should protect it from the top that I was showing you earlier, and those worked out really well also to give good visibility and a little bit of protection. I just went with the standard jack, but they have a whole bunch of options that you can choose from as part of the kit. This installs easily right into the coupler, and I can get a foot or a wheel to put on it, or just put a board underneath like a lot of people do. So that was pretty straightforward. And then I can finally mount the spare tire. Now the spare isn't included in the kit, this is extra, but I think it's a good idea to have a spare with you. You know, you never know when you're going to need it. You go camping or something, you don't want to get stranded out there. Now with the welding wire that I ran through the frame earlier, it's pretty easy to run their wiring harness. And I really like the harness that they included in the kit because it has taillight conductors for both sides, so it's really easy to string through. And then I just used these heat shrink butt connectors for each of the lights to connect them up. Now the trailer decking dropped right in place, and 10 boards worked out to be just about perfect to fit in the space that I had. And I'm just using these self-tapping screws, but these ones do need to be pre-drilled. I'll put a link to them in the description. I just got them off Amazon. They were quite a bit less expensive than the self-drilling ones, and also I didn't really want the points from the self-drilling ones poking through the bottom of the material. So on those angle iron shelves, I thought these would be a better fit, and they were pretty straightforward. I didn't put multiple in every cross member and every board. I felt like that was unnecessary, but I got 2 points at each end and a couple in the middle. And the gate installed easily, and the ramp gate works really well and should be easy to remove whenever I need to do that. Now, the moment that a project is finally finished is always really, really exciting. It feels so good to have something that I made, and it's exactly the way that I wanted it to be. So this is going to be extremely useful when I go get material, projects around the yard, camping trips, all sorts of things. So definitely a great project. Well, the trailer turned out awesome. I'm really happy with it, and it was also a lot of work and took a bit longer than I expected, largely because I was moving a camera around the whole time. Now, was this worth it versus just going out and buying one off of a lot? Well, the kit from Southwest Wheel costs just under $700, and for the steel, wood decking, paint, and a few miscellaneous hardware items, I was just barely over $700. So it's almost exactly $1,400 to complete this build as I did here in this video. Now that is a few $100s less than local builders, and I think that the actual product is a bit better. There's more cross members, it's thicker material, and I think a little bit better craftsmanship because I took some time, but I'm sure those would work just fine. And if you factor in how many hours it took, it's probably not a good hourly rate to do this for cost savings. But if you've been doing welding projects for some amount of time, I think you know that trying to save cost versus something that's mass produced is usually a fool's errand. So that's not really the benefit. For me, every time I use this, I'm gonna feel proud of it and I'm gonna feel really happy using a tool that I built. And that's the value that I get out of this. I also learned a ton about how trailers are constructed, and I know everything about that trailer. And if I were to do one again, I think I could do it in about a day and a half. So there's definitely a learning component there that has a ton of value for me. And also the overall quality of the build, I just think is a little bit better. So for me, absolutely it was worth it, but not from a cost savings perspective, even though it did cost a little bit less. It was worth it just for the satisfaction of doing a project and having it turn out so good. Now I'll put links in the description for this trailer kit from Southwest Wheel, as well as several of the other items that I used here on the channel, and my online welding courses, which will help you to learn much faster than you can on your own. So be sure to check those out. Thanks a ton for tuning in. If you learned something or enjoyed this, let me know by hitting that thumbs up or leaving me a comment below, and we'll see you next time.